A standard hospital ward is defined by multi-directional traffic. Doctors, nurses, and equipment move continuously through shared corridors, exchanging air and surface contact instantly. But the moment a patient undergoes surgery, their internal tissues are exposed to the outside environment. The primary biological imperative of surgery is to prevent hospital-acquired infections, or HAIs, during this window of extreme vulnerability. Standard hospital architecture lacks the precision required for this task. To keep a patient safe, an operation theater cannot be built like a normal room. It must be engineered as an active atmospheric and spatial filter. The core governing principle that makes this possible is a design standard known as unidirectional flow. Unidirectional flow is the absolute physical and atmospheric separation of clean and contaminated vectors. It mandates that people, air, and equipment move in a single forward direction to prevent cross-contamination. Achieving this requires three engineering pillars: progressive spatial zoning, strict thermodynamic controls, and mapped logistical flow paths. Long before a surgeon makes a single incision, the architecture of the operation theater serves as the absolute first line of defense in patient safety. This blueprint shows the footprint of a modern hospital. If we fade out the standard wards, we can isolate the specific architecture of the operation theater complex in the center. To prevent outside pathogens from reaching the operating table, this rectangular block utilizes progressive zonal isolation, dividing the complex into 4 strict color-coded zones. Zone 1 is the protective, or outer zone. This includes the reception desk, staff changing rooms, and the patient holding area. This outermost perimeter provides the first physical barrier. It strictly controls entry from the rest of the hospital and strips away unnecessary visitors. Moving deeper, we enter Zone 2, the clean zone. Here, we find the preoperative rooms, the recovery area, and sterile storage. This functions as a preparation buffer. Patients and instruments are readied here in an environment that is significantly cleaner than the outside hospital, though not yet absolutely sterile. At the center lies Zone 3, the sterile zone. This encompasses the scrub area and the main operation theater itself. The access rules here are absolute. Only authorized staff with an fully sterile surgical attire may cross the threshold into this core. Finally, running along the periphery is Zone 4, the disposal or dirty zone, which houses the dirty utility rooms and waste collection. This zone operates as the exhaust of the complex. It safely routes contaminated materials and soiled instruments away from the clean preparation areas. Together, this 4-zone layout functions as a physical funnel, enforcing progressively stricter hygiene protocols with every step a patient or staff member takes toward the surgical core. Zooming in from the macro layout, the physical design of the main operation theater inside the sterile zone is governed by precise thermodynamic engineering. Looking at this environmental dashboard, the baseline metrics are tightly locked to inhibit microbial growth. The temperature is held exactly between 20 and 24 degrees Celsius, with relative humidity stabilized between 40 and 60%. At the same time, the room requires a massive, continuous turnover of oxygen. The system forces 20 to 25 complete air changes every single hour. This entire volume of air is driven from the ceiling directly through HEPA filters, physically stripping microscopic airborne pathogens out of the atmosphere before the air descends over the surgical table. This constant influx creates an environment of positive air pressure. Because the internal pressure is higher than the surrounding corridors, anytime a door is opened, clean air forcefully pushes out. This guarantees that contaminated air can never flow inward. At the direct center of this engineered downward airflow sits the adjustable operating table, dictating the spatial layout of the remaining equipment. Directly above it are the surgical LED arrays, calibrated to project bright, shadow-free illumination without generating tissue-drying heat. Positioned strictly at the head of the operating table is the anesthesia workstation. This unit controls the supply of vital medical gases like oxygen and nitrous oxide, while continuously monitoring the patient's critical vitals, including end-tidal CO2 levels during general anesthesia. Clustered immediately adjacent to the surgeon's hands are the sterile instrument trolleys, tissue-cutting electrosurgical pottery units, and suction machines for clearing fluids. Notice that the medical gas, vacuum, and electrical outlets are mounted directly into the walls or ceiling pendants. This keeps cables off the floor, eliminating trip hazards and allowing unimpeded movement during a crisis. Every thermodynamic variable and piece of hardware inside the sterile zone is calibrated to function as an active, highly pressurized life support engine. We can see how this strict interior setup connects to the broader complex by mapping the dynamic flow of traffic across the four-zone floor plan. The rule of unidirectional flow requires that all movement occurs in one direction, with zero crossover between sterile and dirty vectors. The patient flow follows a dedicated path. They arrive from the ward, pass through the clean preoperative area, enter the main operation theater, and then exit directly to the recovery room before returning to the ward. Staff follow a parallel but distinct route. They enter the changing rooms, proceed to the scrub area, conduct the surgery, and exit through recovery back to changing, maintaining forward momentum. The logistical supply chain is equally strict. Sterile surgical instruments arrive from the Central Sterile Services Department, pass through the sterile store, and terminate securely at the operating table. Once an instrument is used, it cannot backtrack. It must exit the theater via the dedicated dirty corridor in the disposal zone, passing through the washing room to complete the sterilization loop. Biomedical waste follows a similar outward-only trajectory, moving from the operating room directly into color-coded bins in the disposal zone for temporary storage and eventual hospital collection. Notice the spacing here. The map physically guarantees that the route for incoming sterile instruments never intersects with the route for outgoing waste. Unidirectional flow forces a fast-paced, high-stakes biological process into a collision-free logistical network. By integrating progressive spatial zones, positive pressure environmental controls, and unidirectional logistical flows, the architecture itself acts as an active member of the surgical team. This rigidity is the primary mathematical factor in drastically reducing surgical site infections. By isolating the exposed patient from external variables, the environment does the heavy lifting of biological containment. Furthermore, eliminating spatial friction ensures that staff and equipment can move smoothly, allowing teams to react instantly during a sudden medical emergency. At the same time, the layout safely segregates and expels highly contaminated biomedical waste without ever endangering the sterile core. The modern operation theater proves that concrete, airflow, and spatial design are just as critical to a successful surgery as the scalpel. Architectural engineering is, in practice, a primary instrument of medical intervention.